Let's solve LeetCode 40 combination sum 2. Given a collection of candidate numbers candidates and a target number target, find all unique combinations in candidates where the candidate numbers sum to target. Each number in candidates may only be used once in the combination. The solution set must not contain duplicate combinations. So, what is the input here? Let's understand what the input and output would be. So if this is the input, the output is this. This is different from candidate sum in the sense that we can only use each number once in the combination, and also we may not return the answer in any order. The order needs to be fixed, I believe. As you can see over here, it doesn't say anywhere that the response can be in any order. So we have to respond in the correct order. So my first instinct is, what if we just follow combination sum, right? And in combination sum, what we did is for each element, we found out all of the candidates. But now this time, instead of just starting from the start index, I just go to start plus 1 index. So what I mean by that is, let's take an input array. I'm not going to take this one. This is a pretty long array, and we know that this can be quite long to compute. So we have 252, 1, 2, 252, 1, 2, I believe. 252, 1, 2, yeah. And the target is 5. Okay, cool. So how do we solve this? Well, I like to go and minimize this. So we have an empty array here. Then I have all of the world's possibilities here. So I have 2, 5, 2, 1, and another one, 2. After that, I again go and try out everything, but this time I'm saying that, hey, instead of, counting this 2 again, I'll just count out 5, 2, 1, 2, right? Because this number cannot be included twice. 2 and 2 can be included, by the way, but the same 2 cannot be included twice. In the previous one, we could include twice, and the thing was, in the previous array, all the candidates were distinct as well. So it did not really matter. But this time, it's not going to be distinct. We know that, so let's solve it. So how are we going to solve it? Well, I told you the approach, right? I mean, I can just do this. So for 5, what will happen is I go to 2, 1, and 2 again. All right. For 2, I can go to, 1 and 2. For 1, I can just go to 2. And for 2, I will go nowhere else. I have nowhere else to go. I'm so done. So yeah. After that, what we can do is, for 5, we can again go to 5. Okay, so this can be 2, this can be 1, and then we can again go to 2, and this will keep happening, by the way. So for 2, it would be 1 and 2. For 1, it would just be 2, and for, 2, there's nothing else. So this is kind of what I'm talking about. In each branch, the number of elements will reduce, because instead of going to I, I'm going to I plus 1. So I'm starting from I plus 1 every single time. But here's the problem. Despite that, I'm not guaranteed to have the best solution. Why? Let's take this example. So let's target up to 5. So 2, 5, and 2 will not give me that. 2, 5, and anything will not give me that, because I'm already exceeding 5. So let's try 2, 2, and 1. Correct? So 2, 2, and 1 is stored. That's good. Then I have 2, 2, and 2. That's not it. Then I have 2, 1. I believe this is 1, right? So 2, 1, and 2. And as you can see, here's the problem. Here's the exact problem I'm talking about. We have 2 elements or 2 arrays that are essentially the same. So how on earth can we return both of them? Right? Here, the output only has 1, 2, 2, and 5. So how am I going to return it? We don't know. And the solution to this is actually quite simple. How? Well, what we can do is 2 to 1, correct? I can just sort it. So I have 1 to 2. If I sort this thing as well, I'll get 1 to 2 again. We can store all of this in a set variable called result, and we can append to this set. So if I try to append 1 to 2 two times, it won't be appended. It will only be appended once. So yeah, good. It works. The problem with this is you'll either get time limit exceeded or memory limit exceeded based on how you implement this. So we cannot follow this approach. Also, it is very, you can say, unnecessary, because for every leaf node that we see here, so 2, 5 and 2, so when we get to, let's say, 2, 1 and 2, at leaf node, we're trying to sort everything that we have in the path so far. And we have to do this every single time we find that the target is equal to 0. I don't want to do that. It's redundant. Instead, what I can do is just sort this array in the very beginning, and then I can remove or, just ignore all of the duplicated elements. So what I mean by that is, now I can just sort the array in the beginning. So I'll have 1, 2, 2, 1, 2, 2. I believe there's 3 2s, right? Yes. And then 5. Now what I can do is start with an empty array. Then I'll go and find out all of the elements. So I'll have 1 here. Then I'll have 1 again. Not 1 again, sorry. We're skipping out on them. So 1, 2. Then we have another 2. Then we have another 2. So what I'm thinking of here is that, I have to go through all of these 2s. So what I can do is just skip these 2s. If I get my particular thing in this particular branch, I will also be getting them in this branch or this branch. So I can just calculate the very first branch and get the response. For example, let's see, we have 1, 2 and another 2 here, because this is at index 0, this is at index 1, this is at index 2. All right, so this is the 1. Then let's take another color. This is what I'm talking about. And this is what I'm talking about. Okay. So these are like 3 different elements. The value is the same, but they're supposed to be 3 different elements. So that's what I'm doing here. And we get the response, right? The result is 5 here. So we store our very first array 1, 2, 2. Now let's try it with a different approach. All right. Let me go back. Okay. Our result is now 1, 2, 2. But now see here, I am going to the second 2. All right. Because I already tried out with this approach and I got my answer. So I'll go to this 2. Okay. This 2 will allow me to go to another 2. And then I can find my other answer as well. Right. Because what I've done is this 1 corresponds to this 1 over here. This 2 corresponds to this 2. And then I have my third 2 as well, which comes over here. And we get the same output. So if we go through the same elements, we will keep getting the same answer. So what I can do is, once we have gone through this thing, I can skip these and these. Why? Why can I skip these things? That's because when we were trying out all of the combinations here, we did 1, 2, and 2. Then we did 1, 2, and another 2. Then we did 1, 2, and 5. So we did all of these approaches. So if you again have 2, we are essentially going to do similar things. For example, for this 2, we'll find out 1, 2, and 5. But I've already done that approach. I've already gone through 1, 2, and 5. So why do I have to go through again? So that's why I've sorted. Now I can just check that, hey, if my previous element is the same, then we are going to ignore it. That will allow me to not catch the duplicate. So I can just go through 1, 2, and then 5. I'll skip these things. Great. Let's code it up. So we are going to have a def backtrack. Then I'm going to get, let's say, a path. I'm going to get a target and a start index. Then I can just check that, hey, if the target is 0, I want to store something to the result variable. And then I can just do result.append. Then I can have path here. and then I can do return. Otherwise, the target is less than 0. If the target is less than 0, we are still returning. After that, I'll go through every element in the candidate starting from the start index. So I have for I in range, and then I'll start from the start index, and then I'll go on till the length of the candidates that's present. Cool. After that, I want to pick a candidates at I. Then I can simply add it to the path. So I have path.append candidate. Then I can call the backtrack function, which is path. Well, what is the path over here? Well, this one. The target is going to be target minus the candidate. This is the standard combination sum. We've not done anything differently so far. And the index here is going to be I plus 1. Remember that earlier it was just I, but now it's I plus 1. Because if we are on 1, we want to start with 2 here in the next thing, and then again 2, and then again 2. We're not going to go to 1 again because we cannot have that, right? After that, we will just do path.pop. So I pop off the element, and then I can simply return. First, let's just call backtrack, and then I can do path, which is empty list in the beginning, target, which is target, and then the start, which is 0. Okay. And then we can return the result, but there's a few things to add here. First of all, the candidates array must be sorted now. So I have candidates.sort now. Cool. Now that candidates are sorted, I can go over each one of them, but every time I go, I want to skip out on the duplicates. How can I skip out on the duplicates? Well, I can just check that, hey, candidates at I, if it's equal to candidates at I minus 1, I'll skip it, correct? So for that, I can just do, hey, if candidates at I is equal to the candidates at I minus 1, we skip it. So we'll just do continue, going back to this for loop again and trying out other I's. But one consideration here is that I should be greater than 0 and the candidates at I is equal to candidates at I minus 1. If the candidates is 0, it will just check 0 with the last element, because candidates at 0 is equal to candidates at 0 minus 1, which is the last element. We don't want to check 1 and 5, right? Because, well, obviously we just don't want to. And okay, so now that we have this in place, what will happen? Well, I have 1 here, then I have all of the possibilities, 2, again another 2, then another 2, and then another 5. Cool. So I go to 1 and 2, 3, I get another 2 here. Cool. But here now I'm checking that, hey, candidates at I is equal to candidates at I minus 1. So when I try to do another 2 here, so let me just pause for a minute and explain what's going on here. This is the 1, this is the 2, then this is this 2, this is this 2, all right? So we have multiple duplicates in a row. So what I want to do is now just check that, hey, if the previous one was 2, we have already calculated this possibility. Let me ignore it. So instead of just doing if I is greater than 0, I can just say if I is greater than start. And I should be greater than start because I can either be equal to start or I can be greater than start. I cannot be less than start because we are going from start to the length of the candidates array. So what I want to do is check that, hey, the current index that I'm on, which is 0, 1, 2, 3, this is 3 index and this is 2 index, correct? If you follow the path here, this is the second index. So if 3 is greater than the index at 2 or the index at 1, then we want to skip this particular path. So that's what I've done here. Cool. Let's run it. Accepted. Let's submit. and it works out. Now let's try another thing. If I is greater than 0, let's run it. Will it work? Nope, it doesn't. I greater than 0 will not work because we get 116. It's trying to calculate the same elements over and over again. 116. Two ones are not allowed. So that's why we want to do if I is greater than the start index, because if we give I a possibility to even start from 0, it will give us the wrong elements. So let's, well, run it again, and we've already run the correct answer. So that is it. This is combination sum 2.